Polly the Polynomial Penguin, back talking to you about factoring special products. Now here's a question. What's a penguin's favorite drink? Iced tea!
Okay, first thing we're going to do is review a quadratic trinomial. So that's an expression of the form ax squared plus bx plus c, where x is a variable and a, b, and c are non-zero constants. The constant a is called the leading coefficient, b is the linear coefficient, and c is the additive constant. Again, quadratic means degree 2, and trinomial means there's 3 terms. What I need you to do is be able to pick out what is your a value, what is your b value, and what is your c value. So in this case, we have an a value of 2, a b value of -6, and a c value of 4. The magic x, this is stuff that we've done for the past couple sections. Remember, the magic x, in order to solve the magic x, you must find two numbers whose product is the number on top of the x and whose sum is the number on the bottom of the x. So two numbers that multiply together to make 15, add together to make 8. So that would be 5 and 3. Now let's quickly review the bottoms-up factoring method. Remember, anytime you're given a quadratic trinomial, ax squared plus bx plus c, the first thing you want to do is try to factor out a GCF, a greatest common factor. If you can't, or you do, then the next step would be to use the bottoms-up factoring method, which involves creating a magic x, putting the product of a and c on the top of the x, so a times c goes on the top, your b value goes on the bottom of the magic x. You then solve the magic x by finding two numbers whose product is a times c and whose sum is b. So once you find those two numbers, you divide each of those numbers by your a value, and then you simplify each of those fractions, and then write your answer going bottoms up. So you're going to create two sets of parentheses. In the first set of parentheses, you go ax plus your number. In the second set of parentheses, you go ax plus your other number. Now, when factoring a quadratic expression, we just said the first thing to do is always look for a greatest common factor. Once you do, you take that out, or if there isn't one, then you move to step 2. Step 2 involves choosing one of your factoring methods. So here we have 4 factoring methods to choose from. What we've already learned is the magic x. What we're gonna get into today is the difference of squares and the perfect square trinomials. Now the good news is that these are just shortcuts, just like they were when we were foiling. Factoring using difference of squares and perfect square trinomials, these are just shortcuts. And what you can do if you forget the shortcut is just go back to the magic x. It'll still work, and I'll show you that today. Now let's quickly review what a difference of squares is. So a difference of squares occurs when you multiply the sum and difference of the same two terms. So here we have the sum and difference of the same two terms, a plus b times a minus b. If I were to FOIL that out, I end up with a difference of squares, a squared minus b squared. Difference of squares is a binomial, two terms. A difference, there's a minus in the middle, and both terms must be perfect squares. So like x squared minus 4 or a squared minus 81. And I'll show you how to factor this coming up right now.
Why did the penguin decide not to marry her fiance? She got cold feet!
First thing we always do when we're factoring, we see if there's a GCF. Is there a greatest common factor we can take out from both of these terms? No. So we move on to the next step. Is it a difference of squares? We have a difference, yes, and we have a binomial, and both of these are perfect squares. Perfect, which means we can use our shortcut. So the shortcut looks like this. A squared minus b squared is equal to a plus b times a minus b. The only issue, the hardest part of this whole thing, is figuring out what is your a and what's your b. Remember, it's not x squared that I'm going to plug in for a, because if I were to FOIL that, I would get x to the 4th, and that's not what I want. So a is actually just x, and then b is not 9, right? Because if I were to plug in 9 here and FOIL that, I would end up getting minus 81 instead of 9. So what is the square root of 9? That's what we want to know. So square root of 9 is actually 3. So your b value is 3. So we're going to plug in x plus 3 times x minus 3. And that is how you factor a difference of squares. Now let's say, for instance, you forgot that. Well, this is actually the same as x squared plus 0x minus 9. There isn't a middle term like there usually is. So it's technically plus 0x, because if you multiply that, it's just 0. Now, if you wanted to, you could just use a magic x with this. Your a is 1, your b is 0, and your c is -9. So you create a magic x, you put a times c on top, 1 times -9 goes on top. Your b value goes on the bottom, which is 0. And you need to think about two numbers that multiply together to make -9 and add together to make 0. So that would be positive 3 and negative 3. You then divide both of those by your a value and write your answer going bottoms up. 1x plus 3, 1x minus 3, or x plus 3 times x minus 3, which is exactly the same as what we got when we used the shortcut. Either way works. Let's try this. We have 8 squared minus 36. First thing we always do when we're factoring, we see if there's a GCF. Is there a greatest common factor we can take out from both of these terms? No. So we move on to the next step. Is this a perfect square? Yes. Is this a perfect square? Yes. So it's technically a difference of squares. So all we have to do is figure out what's our A and what's our B. So our A looks like it's going to be H, and our B is going to be the square root of 36. What's that? That's going to be 6. So I go over here, I plug in H for my A here and here. I plug in 6 for my B here and here. Boom, done. Now let's say you forgot the shortcut. Well, h squared minus 36 is technically h squared plus 0h minus 36. So my a is 1, my b is 0, my c is negative 36. So when I create my magic x, a times c goes on top, your b value goes on the bottom, and you think about two numbers that multiply together to make negative 36 and add together to make 0. Well, that would be positive 6 and negative 6. So then I divide each of those by my a value, write my answer going bottoms up. So in the first set of parentheses, I go 1x plus 6. In the second set of parentheses, I go 1x minus 6, or h in this case. And yeah, look, it's exactly the same as what we got when we used the shortcut. Easy.
What do you see on a happy penguin's face? A penguin! You try.
First thing we always do when we're factoring, we see if there's a GCF. Is there a greatest common factor we can take out from both of these terms? No. So we move on to the next step. Is it a difference of squares? We have a difference, yes, and we have a binomial, and both of these are perfect squares. Perfect. So we use the shortcut. What is your a value? Your a value looks like it's q. And what's your b value? Well, what's the square root of 100? That's 10. So we plug in q for our a here and here. We plug in 10 for our b here and here. We're done. Look how easy that was. Let's say you forgot the shortcut though. Well, technically this is q squared plus 0q minus 100. So all we have to do now is make our magic x with our a value being 1, our b value being 0, and our c value being negative 100. That means a times c is going to go on top, your b value goes on the bottom, and we got to think about two numbers whose product is negative 100 and whose sum is 0. So two numbers that multiply together make negative 100 and add together make 0 would be positive 10 and negative 10. We divide both of those by our a value and write our answer going bottoms up. So in the first set of parentheses, it's going to be 1q plus 10. In the second set of parentheses, it's going to be 1q minus 10, or q plus 10 times q minus 10. Exactly the same as what we got in our shortcut. Here, first thing we always do when we're factoring, we see if there's a GCF. Is there a greatest common factor we can take out from both of these terms? No. So we move on to the next step. Do we have a difference of squares? Yes. This is a perfect square. This is a perfect square. There's minus in the middle. Sweet. So we use our shortcut. Our a is going to be x. Our b value, what's the square root of 49? That's going to be 7. So we go over here, we plug in x for our a here and here. We plug in 7 for our b here and here. And you're done. Look how easy that was. But let's say you forgot that. We know that this is the same as x squared plus 0x minus 49 because there isn't a middle term. Your a value is 1, your b value is 0, your c value is negative 49. So we create a magic x. We put a times c on the top of the magic x and your b value on the bottom. We then think about two numbers that multiply together to make negative 49 and add together to make 0. That would be positive 7 and negative 7. We then divide each of those by our a value, which is 1, and write your answer going bottoms up. So in the first set of parentheses, it's going to be 1x plus 7. In the second set of parentheses, 1x minus 7. It's the same thing as if you were to use the shortcut. Now, example 2, we're doing the same thing. So we need to check, is there a greatest common factor we can take out from both of these terms? No. So we move on to the next step. Is this a difference of squares? Yeah, I think it is, right? Can I take the square root of this? Yeah, the square root of 81 is 9. The square root of m squared is just m. So yeah, this is a difference of squares because the square root of 1 is also 1. So I can use my shortcut. So what's my a value? My a value, we just said the square root of 81m squared is going to be 9m. So that's your a. Your b is the square root of 1, which is 1. So we just plug in a 9m anywhere you see an a. So here and here. And a b, we're going to plug in 1 for. So here and here. Look how easy that was. Now for part B over here, there wasn't one in any of the previous ones, but here we actually do have a greatest common factor that we can take out from each of these terms before we use our shortcut. So what can we divide into each of these terms? That would be a 4. So I'm going to take a 4, put it on the outside of a set of parentheses, and on the inside, I divide each of these terms by 4, and I get k squared minus 16. So again, it's important to remove the greatest common factor right at the beginning. Otherwise, if you're factoring something, and you don't remove the greatest common factor, your answer will not be completely factored. We could have used a difference of squares here, but the answer would not have been completely factored. So remove your greatest common factor first, and then now we can use the shortcut for this, k squared minus 16. That's a difference of squares, meaning that we can figure out what our a value and b value are and just plug it in here. So a looks like it's going to be k, and b, what's the square root of 16? That's 4. So we plug in a k for our a here and here, and a 4 for our b here and here. And you're done.
What's a penguin's favorite school activity? Snow and tell! You try.
Okay, so again, always look for a GCF first. Is there a number or variable we can take out for both of these terms? Yeah, 3, right? We can divide each of these terms by 3. So we take a 3, put it on the outside of a set of parentheses. On the inside, we put whatever's left when we divide each of those by 3. So we get u squared minus 25. Now this in here looks like a difference of squares to me, right? We have a difference, it's a binomial, and each of these we can take the square root of. Perfect. So we now factor this using a difference of squares. So what is going to be your a value? Looks like u. And what's your b? What's the square root of 25? That's going to be 5. So we go ahead and put u in for a here and here, and b we're going to put 5 in for here and here. Look how easy that was. Here, is there something we can divide out of each of these terms? No, but we still do have a difference of squares. We can take the square root of this and get 7f, square root of this, 12. Perfect. So let's do this. Here, our a value, we just said if we take the square root of 49f squared, it's 7f. If we take the square root of 144, our b value then is going to be 12. We take a 7f, plug it in for a here and here, take 12, plug it in for b there and there, and you have your difference of squares perfectly factored. Now let's review perfect square trinomials. So a perfect square trinomial occurs when you square a binomial. So here you can see a plus b, the quantity squared, ends up giving you this perfect square trinomial. Over here, if you square the quantity a minus b, then you end up with this perfect square trinomial. The only difference is the sign of your middle term. So here you can see in a perfect square trinomial, you must have 3 terms. So we got 1, 2, 3. 1, 2, 3. The third term is always positive. The first and last terms must be perfect squares. And the middle term is 2 times the product of a and b. Again, notice the signs. That's the only difference between these. So just memorize the form, and then the sign between these is going to be the sign of your middle term. So let's try one. So here, is this a perfect square trinomial? We got 3 terms, third term positive, first and last are perfect squares. Yes, you can take the square root of them. And the middle term is 2 times the square root of the first times the square root of the second. Yeah, so this is a perfect square trinomial. It's the one with a middle term that's positive. So it's going to be a plus b, the quantity squared. So we just need to figure out what's our a and what's our b. Well, what's the square root of our first term? That's going to be w, so that's our a value. And then what's the square root of our last term? That's 1. So that's our b value. So then over here, all we do is just plug in w for a, 1 for b, and it's done. Look how easy that was. Now let's say you forgot the shortcut. All you got to do is use the magic X. In this case, you look, is there something you can factor out? No. So we go, our a is 1, our b is 2, and our c is also 1. Make a magic X, a times c goes on top, that's 1 times 1, so that's 1. Your b value goes on the bottom, 2. Now you think about 2 numbers that multiply together to make 1 and add together to make 2. Well, that's easy, 1 and 1. You then divide by your a value, which is 1. And then you go bottoms up to write your answer. So in the first set of parentheses, it's going to be 1w plus 1. In the second set of parentheses, 1w plus 1. Since they're both w plus 1, you can technically write this as w plus 1 squared. Exactly the same as what we got in our shortcut. Now in part B, again, first thing you always check, is there a greatest common factor you can take out? No. And then you look at this more closely. Well, this actually looks like it might be a perfect square trinomial. Let's check. Is it 3 terms? Yes. Can we square root the first and the last term? Yes. Is the middle term 2 times the square root of the first times square root of the last? Well, this is 11, this is r, so 2 times 11 times r. Yeah, boom. Okay, this is a perfect square trinomial. So what we're going to do now is decide, is it the one where the middle term is positive or negative? Well, it's negative. Therefore, it's going to be a minus b, the quantity squared. That's what we're going to end up with because of this guy. So what's our a and what's our b? What's the square root of r squared? That's r. What's the square root of 121? That's 11. And then we plug in r for a, we plug in 11 for b, and you're done. But let's say you forgot that. You can always just use magic X. Here, again, there's nothing to factor out, so we just go, our a value is 1, our b value is negative 22, and our c value is 121. You create a magic X where a times c goes on the top, and your b value goes on the bottom. What 2 numbers multiply together to make positive 121 and add together to make negative 22? that would be negative 11 and negative 11. So we divide each of those by our a value, create two sets of parentheses, and in the first one we go bottoms up, 1r minus 11. In the second set of parentheses, same thing, 1r minus 11, or r minus 11. Since they're the same thing, we could technically rewrite this as r minus 11 squared, which is exactly what we got when we did our shortcut.
Where do penguins go to dance? At the snowball! Wah, wah, wah. You try.
So again, when we're factoring, first thing we check, is there a greatest common factor? No. But you look at this more closely and you say, oh, this might actually be a perfect square trinomial. Let's check. Is it three terms? Yes. Can we take the square root of the first term and the last term? Yep. Is the middle term 2 times the square root of the first times the square root of the last? Well, x times 3 times 2. Yeah, there you go. Since our middle term is a negative, we're going to use that version of it, where it's a minus b squared. So all we have to do now is figure out what's our a and what's our b. Well, it looks like our a value is going to be x, and our b value, the square root of 9, is going to be 3. So we take x, plug it in for a, we take 3, plug it in for b, and you're done. But let's say you forgot that. You can always use the magic x. Again, since there's no GCF, just figure out what's your a, 1, your b is negative 6, and your c is 9. You then create a magic x where a times c goes on top, your b value goes on the bottom, and you figure out two numbers whose product is 9 and whose sum is negative 6. That's going to be negative 3 and negative 3. You then divide each of those by your a value, create two sets of parentheses. In the first one, we go bottoms up, 1x minus 3. And in the second set of parentheses, 1x minus 3. It's the same thing, so we can rewrite that as x minus 3, the quantity squared. Same thing you got with your shortcut. Here, same thing. Can we factor out a GCF? No. So we look at it more closely. Oh, this looks like a perfect square trinomial. And it's the one where the middle term is positive. Let's check. Is it a perfect square trinomial? We got 3 terms. Square root of the first is m. Square root of the last one is 5. So that works. And then the middle term, m times 5 times 2. Yeah, perfect. So we then use this form and figure out what's our a value. Square root of m squared is m. Square root of 25 is 5. So we take m, plug it in for a, take 5, plug it in for b, and you're done. But let's say you forgot that, you can always use your magic x, where your a value is 1, your b value is 10, your c value is 25. You then make a magic x where a times c goes on top, your b value goes on the bottom. Two numbers that multiply together to make 25 and add together to make 10 would be 5 and 5. You divide each of those by your a value of 1 and create two sets of parentheses. In the first one, we go bottoms up, 1m plus 5. In the second one, the same thing, 1m plus 5. We can rewrite that as m plus 5 squared, which is exactly what we got with our shortcut. Now, example 4, we are doing the same thing. So first, is there a greatest common factor we can take out? Yes, each of these terms has a 5. So we're going to actually take out a 5. We put 5 on the outside of a set of parentheses. And on the inside, we put each term divided by 5. Ooh, that looks like that might be a perfect square trinomial. Let's check. 3 terms? Yes. Can we take the square root of the first? Yep. Can you take the square root of the last? Yep. Is the middle term 2 times the square root of the first times square root of the last? 2 times d times 10? Yeah, that's what it is. So it is a perfect square trinomial. So since our middle term is positive, we use the positive version. This 5, again, is just the 5 that we factored out at the beginning. So our perfect square trinomial, if we were to factor that, we just need to figure out what's our a value and what's our b values. Well, it looks like our a value, the square root of d squared, is just d. The square root of 100 is 10. That's our b value. So we take d, plug it in for a, take 10, plug it in for b, and you're done. But let's say you forgot that. Well, you could always just factor this quadratic trinomial using the magic x, where our a value is going to be 1, our b value is going to be 20, and our c value is going to be 100. Now, all you have to do, create the magic x, where a times c goes on top, your b value is on the bottom. Two numbers that multiply together to make 100 and add together to make 20 would be 10 and 10. You then divide both of those by your a value, which is 1, and write your answer going bottoms up. 1d plus 10 times 1d plus 10. Don't forget about that 5 that was on the outside. If you wanted to, since these are both the same, you could rewrite this as 5 times d plus 10 squared. Part B. First, check, is there something that you can factor out of each of these? No, actually. So instead, we look and we say, oh, this might be a perfect square trinomial because we got 3 terms. Square root of the first, yep, that's 5z. Square root of the last, that's 4. Yep, so that works. And then is the middle term 2 times 5z times 4? Yeah, it is actually. So this is a perfect square trinomial, which means since the middle term is negative, we're going to use that version where we get a minus b, the quantity squared. What did we say our a value was? Well, the square root of 25z squared is going to be 5z. The square root of 16 is going to be 4. So that's our b value. So then we take 5z, plug it in for a, take 4, plug it in for b. Look at that. Done. But let's say you forgot that, you can always just use the magic X like always, where our A value is 25, our B value is negative 40, and our C value is 16. So we put A times C on top of our magic X, our B value on the bottom, negative 40. We then think about two numbers that multiply together to make 400. Their product has to be 400, and their sum, they have to add together to make negative 40. So that's going to be negative 20 and negative 20. We then divide both of those by our A value, simplify, because we need to in this case. We divide each of these by 5, and we end up getting negative 4 over 5 and negative 4 over 5. We create two sets of parentheses, write our answer going bottoms up, 5z minus 4, 5z minus 4. Or in this case, since they're the same thing, 5z minus 4, the quantity squared.
What do penguins call their kids? Children! You try.
Okay, so we look at part A. Is there something we can factor out from each of these terms? Yeah, I think so. Doesn't a 7 go into each of these numbers? Perfect. Now that we've done that, we look and we say, oh, this guy in here actually looks like a perfect square trinomial. We got 3 terms. We can take the square root of the first and the last, and the middle term is 2 times the square root of the first term times the square root of the last term. Yeah, sweet. So since our middle term right there is positive, we use this version where it's a plus b, the quantity squared. And what we can do is just figure out what's your a value. Well, the square root of n squared is just n. And then what's your b value? The square root of 81 is 9. So we take n, plug it in for a, take 9, plug it in for b, and you're done. But let's say you forgot how to do that. In here, if you want to factor n squared plus 18n plus 81, you just use the magic x. A is equal to 1, b is equal to 18, and c is equal to 81. You take the magic x, multiply a times c, put that on top. Your b value goes on the bottom. You then think about two numbers whose product is 81 and whose sum is 18. That's going to be 9 and 9. Divide each of those by your a value. Write your answer going bottoms up. So in 2 sets of parentheses. The first one, we're going to go 1n plus 9. And the second one, we're going to go 1n plus 9. Don't forget about that 7 that was on the outside. You could leave it like this, or since they're the same thing, you could rewrite it as 7 times the quantity, n plus 9 squared. Either way. Here, is there something that divides into each of these terms? Yeah, I think a 3, right? So I can factor out a 3 from each of these terms. I then in here, can I take the square root of this? Yeah, it's 3j. Can I take the square root of this? Yeah, it's 5. So this is actually looking like a perfect square trinomial. Is this 2 times 3j times 5? Yeah, so let's use our perfect square trinomial formula where the middle term is negative, so it's going to be a minus b, the quantity squared. Remember, the 3 is just the 3 that I factored out. Now, what's your a value? We said if we square root that first term, it's 3j. And then if you square that last term, your b value is going to be 5. So we take 3j, plug it in for a, take 5, plug it in for b, and you're done. But let's say you forgot that. Again, you just use the magic x, where your a is 9, your b is negative 30, and your c is 5. Make a magic x, a times c is going to go on top. Your b value goes on the bottom. And now we think about two numbers that multiply together to make 225, add together to make negative 30. That seems a little tough. I think it's going to be 15 and 15, so negative 15 and negative 15. We then divide each of those by our a value. Simplify, we can, yes. So we divide each of those by 3 and get negative 5 over 3, negative 5 over 3. Create 2 sets of parentheses. In the first, bottoms up, 3j minus 5 times in the second set of parentheses, 3j minus 5. Don't forget about that 3 you factored out at the beginning. If you want, you can leave it like this, or since they're the same thing, you could rewrite it as 3 times the quantity, 3j minus 5 squared. And you're done.